I've been trying to design some of the mill into CAD. One of the reasons for that is so I can use the CAD program to essentially make my G-code for me, because FreeCAD has a option for, it's called path, and basically it helps you generate tool paths and code and whatnot. I've actually never used it before, so it's going to be a bit of a learning curve for me, but there's a lot of tutorials out there, so I'm fairly confident that I can do it. Now, I've gotten most of this situated. Sorry, hang on. Itch. I've gotten most of this situated where I think it's going to go, and most of these dimensions are correct. This is an EMA 23 stepper motor. Let's get rid of that. This is a mounting block that essentially I am working on. Let's get rid of that. Now, again, ball screw made shift with just a rod. I didn't actually fabricate a ball screw. But the rest of the stuff is actually to dimension, including these channels. I'm not sure how well you can see this. Let me see if I can. There. These channels are going to be cut out. So what I needed to know, these holes, oops, sorry, all of these holes here are in my linear rail. Let me show you. This is the linear rail for the mill. I measured out each one of these holes and I have it on there in the CAD program. So when I go to drill these holes, it should generate the G-code for me if I'm lucky. Again, haven't done this before, so kind of holding my breath. Now, it's not done because I still have to put bolt holes where I'm going to mount this back plate. This is for the Y-axis. This will mount on the back of the milling machine. So the Z will be going on here, you know, this way, and I still have to design, you know, that stuff. I will probably order a spindle and get everything in the mail before designing some of that, just so I have all the dimensions on hand. I don't want to go through all this to figure out I've got the wrong dimensions, because, you know, it's just a nightmare, and I don't want to waste my time, you know, doing that. Anyway, getting off track here. This is the plate that will be the 1x6 piece of steel. What I'm going to do is this side I'm going to mill flat first. Then I'm going to put this in the mill the other direction, milled side down. I'm going to mill this side flat and then put these channels in accordingly. And I'm hopeful that my machine should be accurate enough so there should, you know, excuse me, be no variation in thickness, or, you know, minuscule. That way, when I have all these linear rails and ball screw mounts on here, there's little to no deflection. I know that sounds like a far stretch, but hey, fingers crossed. Now let me show you how far I've made it on the junction box. I know, you're probably thinking, my God, that's it? and I don't blame you. I gotta tell you, every time I do one of these, I severely underestimate it. None of this is mounted, by the way. This stuff is. But this right here is taking me a few hours, believe it or not. I 3D printed this piece right here. What that does is it's a standoff for the board to keep it centered so I can plug the USB cable into there. I still have to wire up this relay to an output for coolant. I want this to turn on my coolant pump, and this 24 volt fan is for this board and these fans. I went through and I got 24 volt DC fans. I made a mistake on that other box. Let me show you. This is the box for my CNC EDM. These fans are 12 volt and this is a 24 volt supply. So what I had to do was get this buck converter here so I could turn down the voltage for all the fans. Kind of a pain in the neck, but you know, it is what it is. I should have just went with higher voltage fans, but these fans I bought years ago for a different project and just never got around to using them for the right project. One of the things I've been wrestling with is fan position. I made this mount. I 3D printed this, and basically what it's for is to bolt this down to the panel, and then I could stand up, you know, that fan in the box. I just, you know, bolt the fan to that and whatever. A lot of miscellaneous stuff going on here. I also made these out of the skinnier fans. Basically, it's a slot that, you know, might fit in between here that you bolt down, and then you can slide this in to hold the fan for you. Now, I know it probably looks like an overkill, but hear me out. These drivers are good for 50 volts, just about 5 amps, and what I'm going to be running a 48 volt power supply, and the stepper motors require 5 amps each phase. So I'm really going to be pushing these to the limit. So I'm a little concerned about the heat, especially since my garage is 1,000 degrees. That's obviously an overstatement, but you get my point. In the winter time I'll be less concerned, but right now these are going to be running hot as it is, and I'm a little concerned about the cooling part of it. You probably see that I've got X, Y, and A axis here, and of course, you know, the benchtop mill on my desk that I'm converting, I'm not using the Z. I'm not going to convert the Z to CNC. So I have the A here for the dividing head. I'm going to put a stepper motor on the dividing head to make kind of a 4th axis, but I suppose on my mill it'll be a 3rd axis because I don't have the Z. Alright, now that we're all confused, let's keep going. I should be just about done with these junction boxes. I've got 2 projects going on right now. The thing on the CAD program I showed you was the milling machine I'm going to build from scratch. Now, I might use this junction box off of my manual mill. When I'm done with my CNC mill, I might convert my mill back to normal again. Might not, I don't know. So whether or not I'm going to need another box for that mill yet is undetermined. But no matter what, I still do have a CNC plasma table / router table that I'm going to be working on. I showed the extruded aluminum in one of my other videos. I don't remember what it was labeled, but it's going to be a 5 foot by 5 foot table for, you know, whatever, whether it's, I have a plasma cutter and I would like to hook it up so I could cut out pieces of steel. But I also, my daughter loves making things, and I want to also be able to tie a router to it, or, you know, get a spindle for it and make little shadow boxes or whatever. But this is where we're at anyway as far as projects go. I expect it to be a little farther along this weekend, but you know, as the proverbial saying goes, every time I take a step forward I take 3 back. Always seems like something comes up. The milling machine is literally taking every ounce of power of those stepper motors, so I have to feed it every amp and volt that it needs. I do have a backup plan. Let me show you. I ordered 2 of these off of Amazon. They were $20 each, and it wasn't this exactly, but the specs were very similar. They were good for over 7 amps each phase and good for up to 120 volts DC. Only problem being that they're not coming in until probably September. So I really hope that's not the case, because I would really like to get this going. But again, you know, worst case scenario, I don't think it'll come to that, because the machine is running as is, and it's running with a 36 volt power supply. So I'm 99% sure when I upgrade to the 48 volt, all my problems are going to go away. Again, my only concern is the speed at which the mill is moving. It's moving so slow because I have to turn the stepper motors way down to get all the torque I can out of them. And the only way I can fix that is to upgrade to, you know, something like this, the NEMA 34 motor, which I really don't want to do. It just seems kind of pointless when all I'm trying to do is automate some of this stuff for my future projects. Once I have my CNC milling machine, my real one, you know, a lot of this is going to be redundant. So, alright guys, well, I think I've chewed off your ear long enough here. Hope everyone's doing well. Enjoy the rest of your weekend. I will catch you later.